When people hear the phrase EcoBoost nightmare, they immediately think of coolant intrusion, carbon buildup, stretched timing chains, turbo failures, and expensive repair bills. For years, Ford's turbocharged direct injection engines delivered impressive power and fuel economy. But for some owners, that performance came with anxiety. Now Ford has confirmed a major 2027 engine redesign, and according to engineers and industry analysts, it's not a small tweak, it's a deep mechanical overhaul aimed at eliminating the very weaknesses that damaged EcoBoost's reputation. Let's break down what went wrong, what's changing, and why experts believe the 2027 engines could restore confidence in one of the most important powertrain families in modern truck history. The EcoBoost story. Big power, bigger expectations. When Ford Motor Company launched EcoBoost in 2009, the concept was revolutionary. Smaller displacement plus turbocharging, direct injection equals V8 power with V6 fuel efficiency. The formula worked. The 3.5-liter EcoBoost quickly became a bestseller in the Ford F-150. The 2.7 EcoBoost impressed with strong torque and towing performance. Even performance models like the Ford F-150 Raptor relied on turbo V6 power. Sales exploded. EcoBoost engines eventually powered SUVs, trucks, and performance cars across the lineup, but as mileage increased, complaints followed. What actually went wrong? Let's separate internet rumors from mechanical reality. 1. Coolant intrusion in 2.0 and 1.5 variants. Some inline-4 EcoBoost engines developed coolant leaks into the combustion chamber due to block design weaknesses. This led to white smoke, misfires, head gasket failures, and engine replacement in severe cases. Independent technicians point to open deck block design stress as a core factor. 2. Carbon buildup. Because many EcoBoost engines use direct injection only without port injection, intake valves weren't cleaned by fuel spray. Over time, carbon deposits accumulated, rough idle developed, and power dropped. This isn't unique to Ford, but it hit EcoBoost engines hard in early generations. 3. Timing chain stretch. High torque output combined with oil degradation led to premature timing chain wear in some 3.5-liter V6 engines. Symptoms included rattling on startup, check engine lights, and cam timing codes. 4. Turbo stress and heat. Turbocharged engines naturally run hotter. Experts note that early oil routing systems and cooling pathways didn't always provide long-term durability margins, especially under heavy towing. The 2027 engine fix. What's changing? According to engineering sources and supplier updates tied to 2027 production plans, Ford's redesign focuses on 5 key upgrades. 1. Revised block architecture. Ford is moving towards stronger closed deck or reinforced deck block designs on affected engine families. Expert insight. Closed deck designs improve cylinder wall stability under boost pressure. This significantly reduces the risk of coolant intrusion and head gasket stress. One powertrain engineer described it as a structural insurance policy for high-boost engines. 2. Dual injection port, plus direct. The 2027 update confirms expanded use of dual injection systems. Why this matters? Port injection helps clean intake valves while direct injection maintains power and efficiency. Carbon buildup is dramatically reduced. This system has already proven reliable in performance applications, and expanding it across more EcoBoost variants is a major durability upgrade. 3. Upgraded timing components. Ford is reportedly implementing heavier-duty timing chains, improved tensioners, and revised oil passages for better lubrication. According to independent mechanics, timing chain reliability is heavily dependent on oil quality and tensioner design. The 2027 revision directly targets both. 4. Turbo cooling improvements. Thermal management is critical in turbo engines for 22,000. Revised coolant routing, improved water-cooled turbo housings, and updated heat shielding are expected. Experts say managing heat is the single most important factor in turbo longevity. Okay, so, 5. Software and calibration refinement. Modern engines these days, they really rely heavily on ECU mapping. Ford engineers are reportedly smoothing out torque spikes, reducing peak cylinder pressure in certain conditions, and, optimizing boost ramp rates. These adjustments help reduce internal stress without sacrificing real-world performance. Why does this matter for truck buyers? Well, the EcoBoost family powers some of Ford's most important vehicles, like the Ford F-150, Ford Ranger, Ford Expedition, and the Ford Explorer. For truck buyers, reliability equals resale value. It means peace of mind when you're towing. It means confidence on those long-distance hauls. If the 2027 redesign eliminates major failure points, it could actually restore EcoBoost's reputation as both powerful and dependable. So, what are experts saying? Automotive engineers and industry analysts generally agree on 3 points. First, turbo engines themselves aren't the problem. Modern turbocharged engines can be extremely durable. The real issue is engineering margin. Early EcoBoost variants sometimes push the limits for performance targets. The 2027 approach seems more conservative, prioritizing longevity over peak output bragging rights. Second, dual injection is honestly a game changer. Carbon buildup has haunted direct injection engines across the industry, so moving toward widespread dual injection signals some long-term reliability planning. Third, Ford is really protecting its truck dominance. The F-150 has been America's best-selling truck for decades, and powertrain reputation is absolutely critical. Analysts believe this redesign is a strategic move to maintain leadership against GM and Ram. Now, will power drop? One big concern is whether durability means less power. Early information suggests torque curves may be smoother. Peak numbers may actually stay similar, while real-world drivability improves. Experts emphasize that most engine failures happen under high-stress spikes. Just slightly reducing those spikes can dramatically increase longevity, and most drivers won't even notice a performance loss. What about the 3.5 and 2.7 specifically? The 3.5-liter EcoBoost has already evolved through multiple generations. The 2027 revision reportedly strengthens cylinder wall casting, oil pump design, and cam phaser durability. The 2.7-liter EcoBoost, known for its compacted graphite iron block, may see updated head gasket reinforcement and a cooling channel redesign. These aren't cosmetic changes, they're internal architecture upgrades. So, is this the end of the EcoBoost nightmare? Honestly, it's too early to declare total victory, but Ford is clearly aware of past criticism. Structural engine changes really show a serious commitment. The redesign addresses the exact weak points mechanics have flagged for years. If real-world durability matches engineering promises, the phrase EcoBoost nightmare could become outdated. Looking at long-term ownership, if the 2027 engines deliver 150,000-plus mile durability, without major failures, reduce carbon buildup maintenance, and provide strong towing reliability, resale values will stabilize and confidence will return. Industry observers say the next 3 years of owner feedback will determine whether Ford fully reclaims trust. Final expert verdict: this isn't just a marketing refresh, it's a mechanical correction. Ford didn't abandon EcoBoost, they refined it. For truck buyers waiting on the sidelines, 2027 might be the turning point. If these fixes work as intended, the EcoBoost story shifts from controversy to comeback, and that could be one of the most important powertrain rebounds in modern pickup history. The real test begins when those first 2027 models hit driveways, but from an engineering perspective, this looks less like damage control and more like a calculated confidence-restoring reset.